Hi, my name is Cliff Hastings, and this video screencast is called The Hands-On Start to Mathematica. If you're new to Mathematica or looking for a refresher, then you've come to the right place. Today, we're going to go over the basics of using Mathematica. So go ahead and start by opening up Mathematica on your computer so you can work alongside me. When you first launch Mathematica, you should see the welcome screen. From here, you can create a new Mathematica document called a notebook by clicking New Document and then selecting Notebook from the drop-down menu. So let's get started by making our first notebook together. When you create a new notebook in Mathematica, you'll see a plus sign with a horizontal bar and a blinking cursor. This horizontal I-beam means that we are ready to create a new cell. The plus sign is the Cell Insertion Assistant, and clicking on it brings up a menu that allows us to choose the type of input we want. So, for a first example, let's choose Other Style of Text, and then select Title from the drop-down menu and press OK. Now you have a big blinking vertical cursor in our document, and let's type Hands-On Start to Mathematica. Once we are done, let's go ahead and press the down arrow to move the cursor below this cell, and you'll see it turn into a new horizontal I-beam. So we're going to create now a section cell using a second method, and we'll use the menu bar at the top. We will choose Format, and then Style, and then Section, and we'll go ahead and type Entering Calculations. When you're finished typing, hit the down arrow key again to put our cursor below that section cell. Now, a third way to create a cell is with keyboard shortcuts. You can see some of those keyboard shortcuts when you click the Format menu and select Style. So let's go ahead and press Alt-5 or Command-5 if you're on a Mac to create a subsection cell, and we'll call this one Freeform Input. This time, go ahead and keep your cursor inside that cell, hold down the Alt key or Option on a Mac, and press the Enter key. This will create a new cell using the same type of information we just had. So let's go ahead and type Wolfram Language, then hold down the Alt key again or Option key, and press the Enter key to create now a third subsection cell. We'll call this one Palettes. When finished, go ahead and hit the down arrow key, and that'll put our cursor below that cell. Now we are building this notebook. We've made a title, we've made a section, we've made 3 subsection cells. Let's make some text as well. So we'll go ahead and use that keyboard shortcut again. Instead of Alt-5 for the subsection, we'll use Alt-7 to create a text cell, and we'll just go ahead and type, "This is some text." Each cell is indicated by a bracket on the right-hand side of the notebook, and some of these cells are grouped together. Now, the different cell styles in Mathematica follow a hierarchy. By double-clicking the parent cell bracket for entering calculations, it will leave the content in the top cell exposed, but hide the material below. This small triangle on the bottom of the cell bracket indicates there is material hidden underneath. And if you want to show that information, just double-click that cell bracket and it will expand its contents. Mathematica also automatically changes the size or color or font for different cell types to help differentiate them. The look of your document is controlled by the style sheet, which you can change under Format and Style Sheet. So let's go ahead and do that. And now we're going to choose, how about Slideshow and Water. You can explore the different available style sheets on your own, but for now, let's just change the style sheet back to the original by choosing Format and Style Sheet and Default. You can also customize any particular piece of text. For example, let's select the text for Wolfram Language, then we'll choose Format and Text Color and Blue. And if you decide you want to go back to the original style, then just choose that text again, go to Format, and then Clear Formatting. Now, Mathematica offers 3 main ways to enter your calculations. So the first is Freeform Input. Freeform Input is great for new users who aren't familiar with the Wolfram language in Mathematica because it lets you enter input using plain English commands. So go ahead and click your mouse underneath the Freeform Input subsection we made, and then click the equal sign on your keyboard to create a new Freeform Input cell. let's go ahead and type graph 2x minus 7 equals 0, and then hold down the Shift key and press Enter, or hit Enter on your numeric keypad. When you hit Shift plus Enter together, Mathematica sends your input through the internet to our servers with this freeform input style, and then it translates it to Wolfram Language, which you can then see directly below the input, and returns the result, in this case the plot of the line. If you place your cursor over the Wolfram language that was returned, you should see a little pop-up that says Replace cell with this input. When you click on this, the freeform input is replaced by the Wolfram language equivalent of your input. Now we can start to make changes. So for example, let's change the -7 to a -2, and then press Shift-Enter to see how it affects the graph. Again, when we're using the Wolfram language, we don't need the internet connection. When we're using the freeform input, we do, because that's how it parses that language into an actual input and an output. Let's enter another freeform input, but this time we'll use the cell insertion assistant. So click the plus sign on the left and select freeform input. Then we're going to type integral of cosine of 2x and press Shift-Enter to evaluate. To the right of the freeform input line, you'll notice a little plus sign. When you click on this, Mathematica retrieves additional information about the result from Wolfram Alpha that might be of interest, such as step-by-step solutions, or solving this indefinite integral or a plot. When you're done exploring, you can click the plus sign again to hide those results. Now let's click on the output, and you'll see the suggestions bar pop up, which suggests some things you might want to do next. To hide this bar, you can click on the X icon, and if you want to see it again, just go ahead and click on the arrow. One of the suggestions made by the suggestions bar is to simplify our results. Let's go ahead and click on this option, Simplify. Mathematica simplifies our expression to cosine of x times sine of x. Now let's click the suggestion plot, and we can see the results from that as well. So we started with a freeform input, and the suggestions bar helped us simplify, then plot those results without us needing to know any Wolfram language at all. Freeform input also gives us access to a lot of data from Wolfram Alpha. So let's go ahead and start another freeform input cell by typing the equal sign on our keyboard, then type the number of turkeys in Turkey and press the Shift and Enter key together. Mathematica then connects to our servers and returns that data back to you. But not only can freeform input retrieve data from Wolfram Alpha, it also lets you do calculations with this data as well. So let's say I want to find the GDP of Turkey divided by the number of turkeys in Turkey. Mathematica retrieves the relevant pieces of data, and then it will compute that result. Now, freeform input is great for getting started, but using the Wolfram language directly will give you the flexibility and power to tell Mathematica exactly what you want it to do. The Wolfram language is very powerful, but to get started, you really only need to know 4 simple rules. So go ahead and click your mouse underneath the Wolfram language subsection we made earlier, then click the plus sign on the cell insertion assistant and choose again other style of texts, and this time choose item numbered. So the first rule is capital letters to start all function names. Then go ahead and hit the Enter key, and that will create item number 2, and type function arguments are enclosed by square brackets. Hit the Enter key again, and that will use number 3, and number 3 is lists, ranges, and domains are enclosed by curly braces. One more Enter key, and the last rule is Shift plus Enter to run the calculation. Now this last one is really important because Mathematica can also be used as a great text editor, as we've seen a little bit so far. So pressing the Enter key by itself will always just create a carriage return. Shift and Enter together, or the Enter on your numeric keypad tells Mathematica to evaluate some piece of input. So let's go ahead and calculate another integral, but this time we're going to use the Wolfram language and our knowledge from the 4 rules above. So press the down arrow key to create a new I-beam below that numbered list and start typing the word integrate with a capital I. When you first start typing, the function starts out a blue color because Mathematica doesn't recognize the function we've entered, and it pulls up a list of possible function choices. When you select integrate from the list, the function name turns black because now this is a recognized function. You can click on the double chevrons, and Mathematica shows you several possible ways to enter this integral. So let's go ahead and select the second one to calculate a definite integral, and that pastes in a template for us to fill in. So for the function f, let's enter x squared by typing x, and then Control 6 to enter the exponent to raise x to the power of 2. Go ahead and click Tab on your keyboard to go to the next placeholder in the template, and then enter the function variable x, then Tab again to enter the domain for x, from -10 tab to 10. Now notice how the function name integrate starts with a capital I. What we want to calculate, x squared, is enclosed by square brackets, and the domain for x is enclosed by curly braces. When you're ready to compute this integral, then press Shift-Enter. We immediately get an exact result, which is 2,000 over 3. Okay, now that we've entered a few inputs using both freeform input and now this integral using the Wolfram language, let's go on to a third way to enter input in Mathematica and use palettes. So go ahead and click your mouse underneath palettes, then go up to the menu and click palettes and select the basic math assistant. This palette gives you an alternate way to enter things into Mathematica. So let's go ahead and say we want to create, how about a three-dimensional graphic? Under Basic Command, click on 3D, then select Plot 3D. This now gives you a template to enter the function and the ranges with all of the brackets and braces already filled in. All you need to do is then either point and click to fill in the placeholders or tab between them. So for the function, let's go ahead and enter sine with a capital S. We need to do sine of, so a square bracket, x, and then times y. You can either enter a space for x space y or x asterisk y. Either one is fine for multiplication. Go ahead and hit the close square bracket and then tab to the first variable, which is x, and then tab to the min value, which we're going to type negative, capital P, small I for pi, and then tab, and then capital P and I for the x values. Then go ahead and tab to fill in the range for y, which will have go from negative pi to pi as well. This time, for the max, we're going to use the actual button on the palette, and you can click on the pi. So either the function name, capital Pi, or the palette entry of pi, either one is the exact same way. You can also enter pi using a keyboard shortcut. So let's go ahead and go back to that minimum for y of negative pi and hit negative and then escape, pi escape, and that's also a great keyboard shortcut for entering things like the symbol pi as well. Now let's go ahead and hit Shift Enter, and we should get the result of that first 3D graphic. Let's go ahead and click to place our cursor at the bottom of our notebook, and then we're going to press the keyboard shortcut Alt-4 or Command-4 on a Mac to create another new section cell, and we're going to call this Basic Calculations. Now, Mathematica will always give you the most exact answer possible. For example, let's take 16 divided by 728 and evaluate that calculation by pressing Shift-Enter. We get a result of 2 over 91. If you give Mathematica an exact input, it's always going to return for you an exact output, reduced as much as possible. Now, maybe you're wanting the numerical approximation, so we can click numerical value in the suggestions bar to get a numerical result. Now, notice the function is capital N, which means numerically approximate, and what we want to numerically approximate is enclosed by those square brackets. If you want to change the level of approximation to 100 digits, we can simply add a comma and 100 after what we are numerically approximating, and then reevaluate with the Shift-Enter. You can also get a numerical approximation by providing an approximate input. So if you change the input to 16.0 divided by 728, Mathematica returns the result as a numerical approximation as well. Next, let's learn about variable assignments. We're going to create a variable called a and give it a value of 5 by entering a equals 5. Now notice the variable a is in blue. Mathematica doesn't recognize that variable yet, but once you hit Shift-Enter to evaluate the cell, the color for the variable changes to black because a now has been assigned that value of 5. Now you can use the assigned variable for other calculations, so go ahead and enter 3a plus 1, and then press Shift-Enter to evaluate it, and you get the desired result of 16. That variable assignment will remain while Mathematica is running, but you can remove it. You can use the clear command, so enter clear with a capital C, so capital letter on the function name, square brackets around what it is you want to calculate. So you want to clear a, and then hit Shift-Enter to calculate. Now you can notice the a has changed from black back to blue, and when you reevaluate 3a plus 1, Mathematica gives you that result of 3a plus 1, or 1 plus 3a as well. All right, so let's say now you want to solve an equation. So type solve with the capital S, and then open square bracket, and then we'll say 3y plus 12 is set equal to 0. Now when we assign a variable above, we can use a single equal sign because we are defining a to be 5. In this case, we want to solve for y where the left-hand side is set equal to the right-hand side, but just for this one calculation. So when we are trying to solve and find a solution for y, we use two equal signs. So equal equals 0, and then we want to solve for y, so type comma y, close that square bracket, and then we hit Shift-Enter, and Mathematica will solve this equation for y. So a single equal sign is used for variable assignment. Two equal signs means to solve the right-hand side so it is equal to the left-hand side. Now a third point to be aware of is how to define functions. So let's go ahead and define our own function. We're going to make a new input cell. We're going to type f, open square bracket, x underscore, close square bracket, and then colon equals x control 6, make an exponent 2. So f of x is set to x squared. So f is our function name. The square brackets surround those function arguments. The x underscore is a placeholder for something that has this specific pattern. The colon equals in Mathematica means a delayed assignment. So the right-hand side of the delayed assignment is what we want this function to do. Now when you press Shift-Enter to evaluate it, you won't get a result because all we have done at this point is to define that function. But now we can ask Mathematica to compute, for example, f of 2. So we type f, open square bracket, 2, close square bracket, hit Shift-Enter, and we get the result of 4. Now you can also define multiple argument functions if you would like. So for example, let's type g, open square bracket, x underscore, and then comma y underscore, close that square bracket. We're going to use colon equals for this delayed assignment, and then we'll say x control 6 to the y power. Now if you enter g to the 10, comma 10, so g open square bracket 10 comma 10 close square bracket, and then hit Shift-Enter, Mathematica returns that result of 10 billion. We can also use our own function with built-in functions like solve. So let's try solve f of x equal 36 comma x, and close that square bracket, and then we should see that either 6 or negative 6 will satisfy this equation. So while Wolfram Language commands are capitalized, you can see you can use any combination of upper and lower case letters for your own functions that you create as well. Let's go ahead and place our cursor at the bottom of our notebook, and we'll create a new section cell by going up to Format, and then we'll choose Style and Section, and then we will type Basic Graphics. And then hit the down arrow key to make a new horizontal I-beam for a new cell. Now to create our first graphic in this section, we're going to use that freeform input. So type the equal sign using the keyboard, and then let's type graph of sine, parenthesis, x, close parenthesis, and then press Shift-Enter. And as before, we get back the Wolfram Language command that we could invoke directly along with that result, as long as we have that internet connection to take our freeform input and then make a result for us. So let's go ahead and add a label to our plot. Now, one of the choices on the suggestions bar is labels. We'll click on that, and by doing so, that will open up an interactive menu. Let's label the plot sine of x, and then click done. And let's do another one as well. This time we'll create something in 3D. So let's go ahead and go to a new cell, and then we're going to type plot 3D with a capital P and a capital D. We're going to open square bracket. We're going to plot 3D sine with a capital S, and then another open square bracket. X control 6, 2 to say x squared, and then plus, so we're going to get out of the exponent by hitting the right arrow key, and then hit plus, y, control 6 to make the second exponent of y squared, right arrow key out of that exponent, close the square bracket, and then hit comma, open curly brace for our lists, ranges, or domains. They need to be in curly braces. So we're going to say x, comma, -3 to 3, and then close curly brace, comma, open curly brace y, comma, -3, comma, 3, close curly brace, and closed bracket. Go ahead and hit Shift-Enter, and then we should get that 3D graphic from that. Now, any 3D graphic can be rotated by clicking and dragging. So if you click and drag while holding down the Alt key or Command key on the Mac, you can also zoom in and out of that plot. You can also hold down the Shift key and then click and drag, which will pan the image around the cell. Let's go ahead and change our 3D plot to a contour plot by just changing the function name from plot3D to contour plot. Capital C and capital P. So any new word of a function name, they all get a new starting capital letter. And then go ahead and hit Shift-Enter to reevaluate. Now, if you move your mouse over the contours on the contour plot, you'll see little tooltips pop up to show the value of those contours. So go ahead and take your mouse, click at the bottom of the notebook to make a new horizontal I-beam. And then on using Windows, hit Alt-4 on your keyboard or Command-4 on Mac to make a new section cell, and we're going to call this new section Interactive Models. Go ahead and click down or use your down arrow key to make a new horizontal I-beam, and let's type a new 2D plot. We're going to type plot with a capital P, open square bracket, sine with a capital S, open square bracket, x, close square bracket. So far we've said plot the sine of x, where, so comma, x, so open curly brace, x, comma, 0, comma, 2, and then let's go ahead and use the palette to click on the pi button. So we're saying go ahead and close the curly brace and close the bracket. So here we've said we're going to plot the sine of x where x goes from 0 to 2 pi. Go ahead and hit Shift-Enter on your keyboard, and we get that result. Now, we want to actually change this into an interactive model, and the function to do that with in Mathematica is called manipulate. So let's make a new cell, and we're going to type manipulate with a capital M, open square bracket, and let's copy and paste that plot command we did earlier into that manipulate cell. Now, we need a parameter that we're going to manipulate. So let's introduce a new variable right before the x and the sine of x, and we're going to say frequency times x. So frequency space x for frequency times x. Now I'm going to delete that asterisk. You'll see if you don't do that, this is now just a string or a variable called frequency x. So you must, to indicate multiplication, use the space or use the asterisk. Now, once we have this, we need to also tell Mathematica what frequency is. So we're going to go to the very end of our input, click our mouse, type comma, and then open curly brace and say frequency goes from 1 to 5, and then close the curly brace and close the final bracket. Hit Shift-Enter, and we've made our first manipulate model where we have a slider where we can see how frequency affects this sine curve. Now let's make another one. Let's go ahead and use that same input, but this time we're going to replace the function sine with a new variable called function. So with a small f, because that's our own function name, so we're going to define function after frequency. We're going to define it as the list of sine, cosine, and tangent. Now we can hit Shift-Enter, and we can see we have a slider for both frequency as well as buttons for sine, cosine, and tangent. Now, the great thing about Mathematica is you can manipulate anything you can calculate. So let's make a new cell, and we're going to type manipulate again. This time, we're going to manipulate an expansion. So we're going to type open square bracket, expand with a capital E, and then we're going to expand the quantity of y plus z to the nth power, so Control 6 to make that exponent. And then we're going to right arrow key out of that and say n goes from 2 to 100 in steps of 1. And then close the brace and bracket, hit Shift-Enter, and then we should get our manipulate so we can see how the n exponent changes this expansion. Now, making these interactive models is quite simple, as you have seen, but there's also a huge repository of pre-built models that are freely available on our website at the Wolfram Demonstrations Project at demonstrations.wolfram.com. Here, you can browse through demonstrations by topic or search for demonstrations by keyword. And when you found a demonstration that you like, you can download that demonstration to use as an example, or download the Wolfram Language code used to create the demonstration and customize it to your needs. Let's create a new section cell. We'll go up to Format and Style and click Section. So just another way to do that again. This time we'll call it Working with Data. Now, we've already looked at how to access computable data from Wolfram Alpha using free-form input. Now I want to show you how to use your own data sets for calculation as well as importing and exporting as well. So let's go ahead and import some data from a web page. So we're going to use the same data file, so we're doing the same thing. Go ahead and in a new cell type import with a capital I, and then square brackets what you want to import. This is a web page, so we're going to type quotes and then http://www.handsonstart.com and then / the file name is example data scores.txt in quotes, and then we're going to type comma, and then we're going to tell Mathematica to import this as a data file. So we'll type quotes data quote, close the brace, close the bracket, and go ahead and import this, and you should get a list of ordered triples of students' names and their test scores. Now, some things we may want to do is to extract certain parts of data. So in Mathematica, we can use the part function. So we'll type part with a capital P, and then we'll say this file name, what we have called the variable is data1, and then we're going to say comma 1 to return the first part of this data, which is Joe Smith and 94. Now, another way to enter this in a keyboard shortcut way is to say, take data1, and then I'm going to do two brackets, and then the first part, so 1, and then close the two brackets, and then we get the exact same thing. So these are two ways to say the same thing. Now, what if we want to say, show me the first part so take the first part, and then show me the third element of that first part. So we'll type data1, open square brackets, and then 1 to be the first part, and then the third element, so 3, and then close the brackets, and we get back the test score of 94. Or if we want to see the third entity in all of the parts, we can type data1, open bracket, and then all, so show me all parts, and then comma 3 to show me the third entity in all parts, hit Shift-Enter, and we get all of those test scores back as a list. We can also take those test scores we just got and then find the numerical approximation of the mean, for example, of the previous output. So I'm going to type capital N, which means numerically approximate, open square bracket. I'm going to use the function mean, so to find the average, and then open square bracket, and the percent sign means of the last output. So I say numerically approximate the mean of the last output, close the two brackets, hit Shift-Enter, and we see that average is 88.4. Now, in a new cell, let's go ahead and make a new variable called data2, and we're going to import another file. So let's go ahead and type import and then open square brackets in quotes example data, slash 50states.txt. And then again, we need to import that as a data file, not just a big blob of text. So we're going to say import as a data file. And then semicolon means suppress the output. So I don't want to see all 50 states. I just want to see in a new line. So hit the enter key and show me the first. So first, open square bracket, data 2, close square bracket, hit shift enter, and that has now imported the 50 states, and I've asked for just the first element of that data, which is Alabama. So Mathematica has returned the proper answer to us. It's Alabama, but Alabama is just a string. There's no actual knowledge attached to that. But there is a way in Mathematica to get information or get results with knowledge attached, and that's with the function called semantic import instead of just import. So let's make a new variable called data3, and we're going to use set that equal to semantic import, and we're going to import that same file as above, but this time we don't need to tell Mathematica to import it as data. It figures that out on its own. So let's go ahead and type semicolon to suppress that output, and then we'll say show me the first element of data3 with this new semantic import function attached. This time you'll see returned is Alabama, comma, United States with this orange box around it. So Mathematica has connected to our server. It's found some additional information about Alabama. And you can notice that if you look at the suggestions bar, you can see some of the pieces of data are now at your disposal. Things like demographics, labor force, earnings of people in Alabama. And when you select demographics and choose population, Mathematica then returns for you the population of Alabama, which you can now use in your future calculations as well. We're going to make a new section cell. So let's go ahead and use that cell insertion assistant, that little plus sign. We're going to choose other style of text and click section. And then we're going to call this section presentations. Now, the beauty of using slideshows in Mathematica is that all of your text, calculations, graphics, and manipulates are all in a single place. And they all retain their interactivity. So as you're presenting the info in the slideshow, you can interact with these manipulates or make changes on the fly. So let's go ahead and go back up to palettes and open the slideshow palette instead. And from here, you can create a new slideshow. And then you can select the template you want to use. But we've already put a bunch of work into our current notebook, so let's instead create a slideshow from our existing document. Now, after clicking the button to create a slideshow from the existing document, you will see a prompt where it lets you choose whether you want the slide breaks to be inserted. Let's have slides created after the title and each of the section cells, and then click Insert. Mathematica then creates these slides, which you can see on the screen. So let's go ahead and say we want to insert a slide below the title cell. Click underneath the title and click Insert and blank slide. And then if you want to remove that slide, go ahead and select the cell bracket containing the entire slide and click Delete. Now, right now, you're in working mode. When you are ready to present your slideshow, you can go to the slideshow palette and under Settings, click View Environment and change it from Working to Slideshow. Once in the slideshow, you can now use the arrows to move back and forth between your slides. And on the far left is a drop-down which tells you which slide you're on and lets you quickly jump to the slide of your choice. And all of your slides retain their interactivity. So if someone in the audience asks a question, you can make changes to any calculation and reevaluate. Then you can discuss the results, and which makes your presentation much more dynamic and engaging. So I hope you have found this hands-on start video useful to get started with Mathematica. Again, my name is Cliff Hastings, and my email address is cliff@handsonstart.com. This presentation was created from the book, the Hands-On Start to Mathematica book. And it's available on Amazon either in paperback or Kindle versions if you would like a book version to assist you with your start or refresher to Mathematica. If you have any questions or comments for me, please feel free to send me an email. I'll do my best to help or get you the assistance that you need. Best of luck, and I can't wait to see what you do with Mathematica.